Hello. Hi. Uh, Good day to you, evening, afternoon, whichever that would be. We are going to get into conditionals and loops with a little uh, as an addition to some of the other control structures that we talked about previously. And these are various flavors of doing the same thing. That's the big idea here. If statements, if control structures, they determine regions of code that run or don't run, making decisions, yes or no. Switch statements are the same thing, well, with a little bit better mechanics. For variability, and also in the lower level languages, a switch statement, if done correctly, can be more efficient than the normal if statement or ternary based if statement. So switch statements have that capability of efficiency to make it so that it's actually faster than an if statement. And an if statement is essentially the worst thing that can be done for efficiency, and it's also the most common thing that's done. So if you can limit and convert if statements to switch statements, and or if statements to the ternary or tertiary if statement, then you're faster running. However, guess what? We're in Java, so it doesn't really matter. No, we don't care about speed. We want to get results. So it's kind of a moot point. But a switch statement can be used and within or as a replacement for a series of if, else, ifs, else. And I guess we could say it's more efficient. Just another way of doing the same type of mechanism. Let's see if it allows the follow through. So let's look at behavior for the switch statement. Actually, let's get into here. Before we look at behavior here, we got the do loop and the for loop control structures, and looks like a conditional operator. All right, and oh, of course, we're gonna play around with some graphics. I think maybe I'm feeling playful. We might head into that land a bit today. Maybe not today, but we'll see. All right, switch statement. Switch statement. This is how it looks, and then the different cases are the different modifications of your flow, the different control areas of regions of code that will run versus other regions. And let's actually model that. Let's model that. Let's do this. Let's do, this is always a good one that I like to do. Let's do a grade percentage converter type thing, if else. But we'll do it with the if else, else if, and then we'll do it with the switch, and we'll walk through on each one of those. So let's have a grade that we are going to convert to a letter grade based on its percentage value. So a simple variable, percent, and that one is going to be well, it could be, since it's going to be percent, it could be a float. So let's just do double, because we don't care about size. Double percent, that's easy. And then I'm going to hard code percent equals in here. So we don't need to do any user input for this demonstration or for this walkthrough. All right, and for this demonstration, no, whatever it is. I'm being stupid already. All right, yeah, I can tell. It's too early in the morning. I haven't hit my coffee yet. Let me warm up. Double percent 23, and we need to do an if else if percent is equal to, or let's say if percent is less than 95, then we'll say that the grade, and we're going to use a letter for the grade, a string, a letter, equals, we'll just start it off as nothing. Then we'll do letter equals B. And actually, you know what? Let's give that one there. Now this is going to fail utterly and totally fabulously. Doing it this way, obviously, but we're doing demo. We're on. Ooh, that's cool. I hit Control Shift and then something else, and that was. Oh, okay, that was right. Control Shift Z. Oh, nice. Control Shift Z. Oh, that's awesome. Okay. Weird. Let's do this. Because we want it to cascade down on setting up the grades. But if it's less than or equal to 90, then let's set the letter to C. And I think we can just grab this, copy it a couple times. But you notice how I'm just doing one line and I didn't put my my little squigglies. Just remember that the one line, if you only put one line after your if statement, it's implied that it's in the scope of the if statement. Just remember that. Okay. So this is going to be an if percent is less than 95, but we're going to say else if. Else if. Else. And this is going to be less than 90, I guess is B. This is less than 80. I guess that'll work. Less than 70, we'll do a C, a B, D, C. Oh, what am I thinking? Are these grades right? C, yeah, D, B, D, C, B. All right. Okay, oh, right, that's, those numbers are less than 70. Okay, less than 60. Oh, and let's remember, if it's less than 70, else letter is equal to F. Now this is going to fail miserably because the logic is all wrong. Because what happens in between and then the top down behavior, it's gonna, if I roll in a 60%, it's gonna come out as, oh yeah, 60 is less than 90. That's a B. Yeah, so it's the direction of travel of your flow that really matters here, and also the fact that this is if, else, if, else, if, else. So let's look at it and then we'll modify it and see how to change its behavior. So let's put a breakpoint. Now this is very close to what a switch statement is and what it does. Now pretend this is a case and this is a case and this is the default. So what happens here with an if, else, if, else, if, else is that first we make a decision on, well, there is percent less than 90. So let's debug this. And we see that percent is going to be less than 90. So it's going to say letter is equal to B. But notice it's not going to run anything else. It's done. It just assigns letter to B, even though we've set it 23%. So order of operations, or order of how your stuff is laid out, matters in any kind of structure, like control structure that behaves in this manner, and the way a switch statement it matches specific cases, but it also works top down, and it has what's called a fall through behavior. That's the capability which actually makes it more efficient, and has that capability. I can't remember if actually, hold on. Yeah, I'm getting ahead of myself. The fall through ability is specific to a switch statement and is actually what gives it the efficiency compared to a traditional if, else, if structure. And we'll hit that in a little bit. There's also some other things that come with that. But so obviously order of comparison matters. So what if we change this around and we say, hey, if percent is greater than what? It wouldn't work at all. There's no way, because every time we would match one, we need another component. We could convert it. There are areas where this matters, where you do this, where you say greater than 23, and you invert when you check for it, and that makes a difference. So what would it be? If percent is greater than, we would do it this way, 60. Then we would assign a D. But the point is, I guess I didn't really show it as well as I could up here. Order of your checks matters. If one hits true first, all the other ones, you want to make sure that it's gonna look for it in the right order of your checks. It's really hard to duplicate what I'm describing. Let me give you. Actually, no, it's not. We can just continue with this same conversation. Because if we invert the logic now, because we're thinking, oh, let's fix it by inverting the logic, and saying 60 to D, this one would be percent greater than 70. What would it be? Yeah, 70 would be C. Percent greater than 80. Greater than 80 would be a D. So this would be a D, C, B. Else F. And you know, we can do this. Let's add this in. Because I'm just kind of skipping it and being lazy. Okay, so that might solve the problem here of, hey, score of 23. Now we start out that the score of 23, hey, is percent greater than 60. No, 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 F. Or whatever. This doesn't even have to be there. It works. Woo! We changed the order. It works. But then we look at the other side of it. So what about 95? So now it fails. So there's limitations to, because this simulates sort of a case or a switch statement with simple cases. However, when you modify a switch and you start having a switch statement that works on arrays, and you can modify the behavior of the switch based on that array, that's gold. That's good stuff. So switch statements have their use. So let's get to them. But how would we solve this so it behaves appropriately? Well, we would do a logical and check the other side, and then we wouldn't have this problem anymore. Yeah, this insanity, it's driving me insane. If percent is greater than 60 and percent is less than 70. Okay. Somebody's got to take it. Less than equal to. All right. And I would do that for all the other ones. I would add it here for this one, modify it to 60, add it here, modify it to 70, add it here, modify it to 80. And that's an example of how the direction of your flow matters in these type of control structures, where the behavior is going to be based on, what happens. Now let's actually demo this without the changes, so you can see it fail, just for fun, because we haven't done it. All right, and then we're going to go right here. Percent is greater than 60. Great. D. Boom. F. You're out. But that's the idea. Now, what it's going to do is continue to check these, and it will check all the way down to here before it finds it's out, and then it goes down to its continue running, and everything else is skipped. The same with this one. It'll continue to look, but if one is found, if one runs, if one of these is true, then that is the only one that runs for this whole block. So where you put your secondary else if or your secondary check matters, because that's order of operations. That's what this is essentially. That order of operations. Check that, that, and then one of them matches. Oh, we're good. Let's continue on away. Printout done. So switch statements. Same behavior, different, a little bit different structure. So let's do this. Switch on percent. And we have a scope for the whole switch statement. And then we are going to say, hey, what case do we have? Percent less than or greater than 70. Actually, you know, this is a horrible example. Let's go back to the PowerPoint because I wanted to cover else ifs, just to show you the beginning structure of, or the similarities between it and the switch statement. So let's go back over here to this switch PowerPoint, and this example of switching on a char. This is where we're switching on a char character, and we're saying, hey, whatever we pass here, whatever variable it is, I'm going to give you a match for what it actually, the value that it could contain. And if it contains that value, I want you to perform these instructions. And then I want you to break out and we're done. Now this one is famously an easy one, and that is doing an example of a case, and it also demonstrates the pass-through or the fall-through behavior, and that is for a to do a character check, a case, uppercase, lowercase check on a character. So, and a switch is really good for that. And we could look at the character itself, determine whether it's, well, here, let's look at it. And this one would be for a menu item. Maybe we were asking for a yes or a no answer. And let's say that we have a menu item. I wonder, let's see. The Java switch statement allows you to switch on a string. Not lower level languages don't allow that. I don't believe the recent update does see now. But we can actually have a letter that we're going to use as a string that's going to determine a menu option, yes or no. And I'm going to have the user enter in the Y or the N, and they can enter it year, and it's pretty common, or NN. That's what they can enter it. But that's not what I'm going to be setting this letter equal to. But that's what I'm going to be, the user can enter in is a year, not a year. What am I saying here? I'm being weird. A yes or a no. Why am I doing year? Okay, please, yeah, take that back. Rewind a little bit. Yes, yes. Common, yes, yes. Menu option choice that we see in command line programming, and we need to just say, hey, did you press the yes key? And so what we'll do is we would switch on that letter, and that letter, we would allow the program to continue or not if that letter matched Y uppercase or Y lowercase, because that's all we care that the user enters is just yes or no, Y or N. And so what we would set up is a case statement for that, or you could do it as an if, else, if, else, if. However, the case statement allows for this particular behavior, which is nice, and actually is what allows for some higher level of efficiency with switch statements. And switch statements can get or can be used to usually what I do is when I'm developing a program, I will start with just straight up if statements. Then I will try to modify those if statements to the tertiary version, whatever, I always forget that, of an if statement. The really simple one with this question mark, it's kind of a stinker. And then, or depending on the complexity, I will modify as many or as much as possible, get rid of if statements so that it does either a tertiary if or a switch statement. Well-placed switch statements are very helpful for speed. I don't care whatever, speed is always a deal on computers and software and stuff, but Java, we kind of like, people like to be cavalier and say, oh, it doesn't really matter. So we would say, hey, did you push yes? Then we would say, this would be, and we're just going to do a simple, I think I got the syntax wrong on that. Let's look at the example. What am I doing wrong here? No, yeah, that's, silly me. All right, there we go. And for this case, now notice here that I'm tabbing in the case a little bit here, and then under each case, I tab in the what is actually going to happen. So in this case, we would return a true or something from a function, but we would, in this case, we're just going to do a simple out dot print. Yes. Okay. And then, excuse me. Now this would be just a simple little menu helper that I would create if I was doing a CLI or command line interface. CLI, command line interface. And they're pretty common, guys. A lot of the back end stuff, like the compiler we're using right now, is all command line. All NetBeans does is send the code off to it to be compiled. But you didn't know that. Well, actually, no. Oh my goodness. Let me rephrase that. The Java virtual machine, yes, to be interpreted. Yeah. We got yes, no. Lowercase now. Quit being silly. Yes, yes. That's what it would be. And then this would be no, and then no. Now let's modify this and look at behavior. Okay. Yes, yes, no, no. We're good. Let's do a clean. Okay. All right. Now we look at behavior. And let's say that we ask the user for this option. And the user typed in Y. That means then when the switch runs, it looks at the letter, it looks at the value in the letter, which is the capital Y, and then it starts from top down. So remember, the order is important, just like your if, else, if, else, if, else. The order of where you put the case is important. Right? Okay, good. So it found, and it says, yes, we are good. The user pushed yes, continue. Versus if we say no, it would then match this one and we would print no and continue. But what if somebody entered in a bunch of hooey? Like nothing. That would be a problem. What match would it get? So let's see what happens. Okay. Okay, we got a bunch of hooey in there. Is it going to match anything? We got a whole bunch of nothing in there. It doesn't match anything. All right. And then, let's see. This is where switches come out. They come out to play and have fun and dance merrily around the park. Because what a switch allows you to do is what's called fall through. Not every language allows fall through, guys. There's some of them that don't. Don't JavaScript. I'm thinking JavaScript. Some of you just shout out, yeah, JavaScript. But I'm thinking JavaScript doesn't allow. I could be wrong though. Follow through is when you say, hey, what's going on here? Why am I doing two regions of code for the same thing? And what you can say is, oh, well, what happens if we just say, if case Y, then we just fall right down through to the other check and run that. And we get rid of all that code. It's so much more efficient. It's kind of streamlined. And there's even tools that make this efficiency more apparent on the back end as well. And then, if you really want to get crazy, you start switching on array lists. And then you see some craziness coming. But I'm not talking about for this example. Yeah. This example is just simple menu, yes, no. What did the user push? A switch mechanism. And that's why we call it a switch. And so it's meant to stay as simple as possible for that speed, and because of its simplicity, we get stuff like this. That are nice little gems for efficiency. So we actually don't need this. Okay, so let's demonstrate fall through. Let's say we are lowercase y. Make sure that I'm not being a liar. Okay, lowercase y. Okay. And yeah, it doesn't really show you the comparisons, but you can see the path. We switch it to an N, uppercase N. And then you get your path. Okay? All right, remember, order matters. Cases are simplistic by design for efficiency. If you're able to take an if statement that is fairly complex and make it simpler to fit inside of a switch statement, or as a switch statement, or as a ternary, tertiary, whatever if statement, then that's the next step. But then again, hey, pick your battles. Where are they at? And then of course some of them are just more elegant and easier to code. There's that too. So let's go back into other stuff. We talked about that. Let's get into the for loop. I'm not covering the do loop. This one, the for. This one, the for. Let's cover this one. This one is actually the most common loop, and I would suggest that if you were going to have a loop, this would be the very first implementation of it. While loops are more for some automation. A while loop is more for automation, and the do while is meant for automation that at least needs some kind of pre-check before automation happens. And it's really good for input. It's really good for input authentication. So the for loop has the three components of what a loop needs. What it's initialized, its counter, and then what is the condition? What kind of Boolean or how often is it gonna count? And then every time it increments, how much is gonna increment by? And usually it starts at 0 and it goes to less than however amount of memory that you have, that you're working with, whatever it is. And for loops are used commonly to traverse arrays, array lists, and other things of that nature. While loops have the ability to traverse more complex things like linked lists and such like that type of memory structure. So you're going to live in for land for a lot of your programming is with for statements within local scope. It's bread and water. It's the staple. It's the rice. It's along with if statements. For loops, if statements are bread, water, and rice. And yeah, that for loop and if statements, that's what's used the most. So let's look at how a for loop behaves, and let's use it within context. Yeah, let's put it with it. No, let's roll it through with just numbers. That's going to be easy to work with first. Control Shift Z, or is it Control Shift Z? No. Dang it. It won't do it now. Dang it. Okay. I guess I thought I had it figured out. But you can just do it right here. Yeah. I'm just going to tuck it down here, just in case. Yeah. Go away. Go away. Bye-bye. Now this guy's going to go away too. All right. For loop. Int I. Okay. This is what's nice about a for loop. It's traditional that we start it with I. And the reason why we put and I'm gonna tell you guys, always start your for loops at 0. Just you're not, you're doing something wrong. Plainly. No. This int, saying that it's int I, means that when we are instantiating int I from within the for loop, what it means is, the way the language is structured, is that the int is only, I is only in the scope of the for loop. So if I had an integer I out here, this integer I is not the same as this integer I. So in other words, I can't go out here and just say I equals 4. I can't do that, because that integer I is only available within the scope of the for loop. And so when you're working with a for loop, make sure you define and initialize your counter within that scope, and so it's safe. And that's usually the way we do it. And then we go in, and if we have nested, we usually do J. I don't know why. I'm sure there's papers written on why we do stupid IJ stuff. I don't know why is it not KLM. Well, sometimes it is. Sometimes I even use V. And sometimes I get really crazy and I use J. But it's your counter, it's your accumulator. And then we have your iterator. And this can be, this iterator right here, can be I is equal to I plus 1. You can do that. You can do I is equal to I plus 4. And this loop would probably only run once. Yeah, it would only run once with that accumulator, or with that iteration. So every time through, I will start at 0, and then when the flow starts its repetition within this scope, I is going to be increased by however much you add in here. So let's do it like this. Let's do 50. Let's just do 50 so we can see what's going on here. And then let's do this. Let's do system.print. What are we printing? We're printing I. Why not? Yeah. Print 9. Oh, let's do a print line so we don't have to inject a new line inside of a number. Oh, and this should be out. Hey, great, yeah. Got away with that for a little while. Wow. All right, set a breakpoint. Let's look at what happens. So here's our condition. We will run as long as I is less than 50. All right, we're debugging now. Okay, my runtime's here. I starts out at 0. We probably may not see this in the variables because I don't think it's on the stack yet. It's not in the scope yet. So you see I is not known variable. These are a bunch of old ones that I got to actually remove. I think I can just hit delete, yeah. I don't know if I should hit delete though. I don't, I don't know what I hit delete on, maybe. Yeah, whatever. Okay, I'm gonna step over. There we go. There's I. Okay. I didn't delete too much. I want a little, yeah, there here was static main. Yeah, okay. So I starts at 0 and then this runs now. And we got I then goes back up to here. The runtime goes back up to here. And now, so I, ran. It just ran at 0. And if we look at our output, we should see enormous output. No, what the heck is going on? Let's see what we got going on here. All right, we're going to see that I is 0. We're going to look at our variables here. I is 0. And step over. We print I. Now I is 4. Did the output happen? Not yet. It probably, okay. Well, let's see what happens. Then, no output yet. All right, I is now 8. So it starts at 4. Now I is at 8. Let's see what's wrong with this. The print. Actually, you know what? Let's just run it through. Because what it's doing is it's adding 4 to I every time. And if you look in the variables, I'm getting distracted because I want to get the output. I want to see the output, but we're probably not there yet. 28, 32. So the I is just going up by 4 every time, all the way until it gets to 50. So the for loop, the beauty of it is that it's everything all put together. It's your counter that's scope protected, and your condition that's scope protected, and your accumulator that's scope protected. That's where the for loop and the if loop, or not loop, if statement are that's why I talk about bread and butter and the staple. If statements, for statements, the staple of most of what the control structures you'll be using. Okay. Let's play this through and just run it. And you see the output. Now, it was being a stinker probably because it was on some other queue for the output to happen, or I don't know why it wasn't showing it during debug. Let's actually mess around with that and just double check because it's not on me, because usually I can trace it. There we go, 0. It's like, it's not like we don't have the debugger to do our output for us, essentially. We don't really need to do it. Okay, why is it? That is so odd that it wasn't showing up. Okay, well, there we go. Okay. That's what I like. Alright. So I'm going up by 4 every time. Oh, NetBeans, I love to hate you. I love to hate you, NetBeans. You are such a... okay. Yep. Time to move on. I++. That is the most common. That is the post increment. So remember, we want it, if we do it plus I, it's going to increment first, and then everything else will be done in the normal order. versus everything else will be done. Everything else will be done. And then the increment. So essentially increment after you're done iterating and completing the body of your first run. So we don't start off by iterating. Iterating is only after the initial completion of these guys. And so that's the distinction between I++ and ++I, is that ++I means that it's going to iterate before anything else is evaluated loosely. And then everything else is evaluated or done, and then the increment. So when we first run, when we say print line of I is going to print out a 0 first. Then it's going to come back and it's going to do its initial test. After that, or after its first initial test, I++ is able to happen. All right. I think let's see it in action. Let's see it in action. Just run them one at a time. Real simple. And the variables. Let's trace it with the variables. And it's not going to come into scope yet because this line hasn't run yet. And boom, that line runs, and then I is up there. We'll see it up on the board, and we're going to see it in the output. You see it's just going up by 1. Okay? All right. It helps just to get in here, guys, and play with it. It's just things that are moving around. Numbers within numbers within, yeah. All right. Where are we at here? I wanted to capture for statements and if statements, or not if statements, but switch statements and the break and for statements. That's the main thing I wanted to capture for this talk. One last bit, actually. Now, we talked about the for statement being bread and butter. However, with higher level languages, they have what's called the for each statement. And that is a higher level loop that lower level languages don't have, but it's the ability to walk through a list with what we call an iterator, essentially. And the iterator is what we create, and we say, hey, I want a book called My Book that walks for all the books that are in the book list. And it will assign My Book to the book list's 0 element first. And that is where we have the ability to take containers and traverse containers of objects using that for each statement. And it's a for each loop for every item in here. And we can do that with a string. It's better to do it with a higher level object. And we can do it for the die object that we have here from some previous code in your book, the die object. So what we can do is we can create an array list of die and traverse it with the for each. We can traverse it with the for loop. You know, we've been doing that too, but we can do it with the tricksy for each. Let's do it with the tricksy for each. So let's do a array list. And actually, you know, we could just Oh, look at that. That's funny. We're doing it too. Let's see. There we go. We're going to do that. But no, for a die. Do we need includes? Yeah, we got it right here. Array list. Array list. Dice equals new array list. Is this where I put my template? I think it is. I'll look it up, but I don't, whatever. We'll do this as die. So we're going to have an array list of die objects from here. And they can roll, they can be rolled. We can have a face value, get face value, etc. And then we're going to have the ability to loop through them. But here's the thing. And let's actually look at an example of an array list. Yeah, I'm being silly. I'm writing in the wrong code. I'm writing in C++. Die. Okay. And then this one we lose blank because it's just an empty reference to the array list of references. Yeah, it's a pointer to a pointer. So, did I get it all the way? Let's do just a simple clean and rebuild. Okay, we're looking good. Build successful. And now we can't just have an empty reference to items on the heap, so we've got to instantiate some items, some dice rolls. So what we're going to do now is we're going to have 50 dice we're going to roll in the table. Why not? We've got a loop that runs 50 times. We should be able to roll 50 dice on the table. Let's do it. So every time through this loop, I can add a new dice roll or a new die to the array list by saying dice dot add die E. Okay. Well, what's die E? Well, E is going to be the new die that I put in here. Well, new die has to be instantiated. And we can do this a couple different ways, but the easiest way is just, we could say, die E equals new die. We can do that and then add I, and then add E. Let's just call it the dice. And then this, the dice. But then I'm like, well, why do we even need to freaking name it? I'm like, the hell with it. Why don't I just take what this returns and throw that stupid thing right in here and the heck with the other stuff? Because it's the same thing. It's the same thing. And that's what's cool about higher level languages is that ability. And then we can do dot whatever crazy stuff on stuff. But anyways, let's do that new die. But what about a new die? Let's look at the die constructor. This is in your book. So let's do the roll int value, set face value. Let's do this. Let's have it roll. Let's have it roll first. And then when it's instantiated and we send it nothing by default, because that makes sense. If we're not setting a face value, then we should have it roll. Sure, why not? By default, and then we'll set the face value to the roll. So we could say, what is it? Int, or wait, it would be double R. What would it be? No, int R equals roll. And then set face value of R. But then I'm thinking, well, same thing applies, doesn't it? Why? Isn't the roll, what does the roll do? It returns a value. We could use it there. Oh, doesn't it set the face value? Oh my God. That was it. That can be even a little simpler. Oh, geez. All that work for just a little bit? Okay. Yeah, because we already got it. Face value is equal to when we roll. So we just roll when we set nothing. And when we send it something, that's when we want to override a normal dice roll or dice behavior on instantiation, which would be to roll the dice, because that's the whole point of dice, is to roll it. So let's roll it right off the bat. So now the die rolls. Notice we're passing nothing. So our constructor that we're running is that roll one. And let's do a step into for that. So I'm going to set a breakpoint here. I'm going to run through this baby. Let's see. All right, step over, add a new die. Now this is where I'm going to step into. It's not going to add it yet. First, we're calling new die. Now that new die that we're creating is just a temporary, behind the scenes, implicit, anonymous variable. And we call it anonymous because it's not being named. It's being passed as a return to a function. Yeah. So we get this anonymous object and we can step into its construction. We should be able to. Come on. Okay, we're going to have to do stepping into all the way. Let's see if we can go all the way through the other side. Come on, give me some love. Give me some love. You got to be in there. No. It didn't want me to, it didn't allow me to step behind the scenes. Damn. We're going to have to set the breakpoint for that? Oh, I thought it would let me through. Okay, the hell with it. Okay. All right. All right, so continue. If I continue from here, and the goal is to get that new die constructor to run. That's what I'm trying to get. And so I want to verify that this is actually happening. Oh, actually, you know what? That's why. Oh, I'm being silly. I built the whole thing to behave that way. All right, that with it. Let's go back to the scene. All right, let's go through here. Let's get something that actually is working and is not being silly. Okay, we got to go back and zoom in again. All right. Let's take it from the top. Sidetracked. Let's see. Let's make sure that that sucker is running. Please be working. Okay, so we got the constructor. This is the one we're testing, not that one. Okay, dude, get with it. And then over here, we got our our continue, and it should hit us. It should hit us when I do a step over, or I can hit play here, continue, and it'll continue right over through the roll. All right, now it should work. That's why it didn't work, is because it was going, when I was doing step into, it was going through the back end code of that error happening when it did add member stuff. It was, yeah. Sometimes you can step into utility code and then back out to your code when you have that's multi-threading. That's not what we're doing. So yeah, whatever. All right, we roll. We're rolling. Cool. What are we doing with our roll? Well, let's find out. We add the die. Are we doing with it? No, we've just added 50 rolled dice. And we could actually do this. We could do a quick int I equals 0 here as a dummy to set a breakpoint, just to look at it in the, well, let's get rid of that. Get up, go away. Go away. All right. Okay, I'm going to do the continue. Okay, there we go. So I just stopped the program here so we can see what happens after this is run to the dice variable. And if we look into the debugger in debug mode, we can break down dice and we can look at all the dice. We don't even need to worry about the output. Who cares? You know, I'm not worried about the output right now. I'm looking into it and I see that face value is a 2. That looked all right. Face value is a 3. Now, does this have the string overload in it, or override, or the toString? Not override, but function. Yeah, so we can print it easily from the list. So it's going to get even crazier. Now we can walk through and traverse this list and print it in 2 ways. And what got us all started on this whole thing was the for each statement. First, let's demonstrate doing it with the for statement. Now we're not going to hard code it. That was just, we're hard coding it just to see the size. Now we're going to do dice.size. That's a function that returns the size of how many dice are in there. And notice how I'm going to less than size. Look into the inclusive exclusive stuff, guys. And off by 1 errors. That's why I'm telling you, start at 0 to less than. We're just going one time. We're just going 1 by 1. And then what we got to do is we have to get the index. So we got to say dice. Now, how do we get the index of an array list and print out the array list? And to traverse it, we really want a variable that we'll use on the stack. It's going to be one of the main ways to we're going to use it to get items from the stack on the heap, which the items are going to be dice. So it's just going to be a simple dice variable. And it's going to be a die called current. And I'm going to set it to nothing. I'm not going to instantiate it. Why? I'm just using it to reference the dice. So let's see if that'll work. We'll try. Yeah, it's just a pointer. So I don't need to instantiate it because it's already instantiated on the array list. I just need something to point to the current one that I'm on. Dice.get index of I, because I need to use the get function that returns a new die, or not a new die, but an actual, the die at that location. Let's see if this, it should, yeah, let's see what I'm doing. If I'm doing anything wrong, I think, oh, no, everything's good, okay. All right. So I set the breakpoint here. It all ran up to here. So let's actually look at that. Let's run it. Let's start right here. Okay. No, come on. I set the breakpoint up here. You are being such a stubborn ape today. Dang. I'm talking about myself. Whoa. All right. Array list dice, new array list. That's instantiation of the reference, not the dice, the reference for the array, or the array list, not the die. But we're going to be adding the die here. Now this is a reference only. It's not instantiating any dice at all, or any die. It's just a reference to a, if we wanted to instantiate it, we'd say equals new, and then we would get the reference to the address of that location from what the operating system released from that location in RAM on the heap. But we already have that memory instantiated. We just need to get the reference to that memory, and then we can reference it with that reference, which is called current. And we get it at I, so we can then say print, oh wait, system, because the whole goal is just to traverse it. Print, now we're going to do the print, float, or double or whatever, print, and what we're going to send it is current dot face value. But we're going to have a problem with that, because face value, isn't it? Oh. Ooh, that gives me the heebie-jeebies. Why is that public? No. No. I need to save some face value here. Oh my goodness. Okay. Yeah, I just said that. That means we need to move on. That means I'm getting silly. Okay. All right. Face value we don't have access to by design, which is appropriate. So let's hit stop. Let's go back to here. And we need to say currents get face value. That's appropriate. Okay. All right, now let's run through that. Okay, now I don't want to go through all 50 of those, so I'm going to hit a breakpoint here, and I'm going to hit continue up here, and it'll run to that point. There we go. Now I'm going to step over, and I see get I here. I is doing what it should be doing. We get the first one, and then we print it. We keep doing it, and if we look at the output, you see we got 5, 1, 4, 3. So we should make that print line, and then we can just rock and roll with it. Let's just do it. Good deal. All right, 50 dice rolls. All right. And then I'm looking at this and I'm like, well, this is Java. I can do some crazy crap. What kind of crazy crap? Okay, well, I don't really like this current equals dice.getI. Why am I doing that? Why can't I just do this? I'm so lazy. Let's just do this. Let's be nutty. Huh? Why do I even need current? Let's just keep it anonymous. Why not? Just reference it right off. Will it work? Will it run? Yay! Alright guys, do those baby steps though before you start getting a little wild with this kind of stuff. Alrighty, that's enough for this one, guys. Really, we've gotten through some good stuff. Next up, take care, guys.